What if the next great city isn't on Earth, but on the moon? Not a base, not a science outpost, but an actual city, built for humans to live, work, and maybe even raise families beyond Earth's atmosphere. It sounds like science fiction, the kind of dream we used to see in movies or old NASA posters. But right now, that dream is starting to take shape. NASA's Artemis program, along with private space companies and international partners, isn't just planning to land on the moon again. They're planning to stay there. This isn't a repeat of Apollo. There won't be quick visits or short flag-planting missions. This time, it's about building something that lasts, something that will completely redefine what home means for humanity. But how do you even build a city on the moon? Where would you find water? How do you survive the freezing nights, the radiation, the storms of sharp lunar dust that can tear through equipment? And most importantly, what's the real reason NASA wants humans living there in the first place? Today, we're diving deep into how NASA, SpaceX, and a growing number of scientists are turning the moon from a barren rock into humanity's first off-world civilization. Because if this mission succeeds, Earth won't be our only home anymore. For over 50 years, the moon was just a memory, a distant gray rock that humanity had already conquered. After the Apollo missions ended in 1972, NASA turned its attention elsewhere. But in silence, one question kept haunting scientists and dreamers alike. What if we never should have stopped going? Now, decades later, that question has become a mission. NASA's Artemis program is the boldest lunar project ever attempted, and it's not about visiting. It's about living there. Artemis isn't just one rocket launch. It's an entire roadmap, a carefully planned sequence of missions designed to create a permanent human presence on the moon by the end of this decade. The idea is simple, but the goal is extraordinary. Build a sustainable outpost where astronauts can live, conduct research, and prepare for the next great leap, Mars. The plan starts with Artemis I, which has already proven that NASA's Space Launch System, the most powerful rocket ever built, can reach lunar orbit safely. Next comes Artemis II, scheduled to carry humans around the moon for the first time in more than half a century. But the real game-changer is Artemis III, the mission that will finally land astronauts, including the first woman and the first person of color, back on the lunar surface. This time, they're not landing anywhere near the old Apollo sites. They're heading to the lunar South Pole, one of the most mysterious and dangerous regions on the moon. Why there? Because it's believed to contain vast reserves of frozen water buried in shadowed craters, the single most valuable resource for survival. Water isn't just for drinking. It can be split into hydrogen and oxygen, creating rocket fuel and breathable air. In other words, water is the key to unlocking everything, from long-term habitation to interplanetary travel. Because if this mission succeeds, Earth won't be our only home anymore. For over 50 years, the moon was just a memory, a distant gray rock that humanity had already conquered. After the Apollo missions ended in 1972, NASA turned its attention elsewhere. But in silence, one question kept haunting scientists and dreamers alike. What if we never should have stopped going? Now, decades later, that question has become a mission. NASA's Artemis program is the boldest lunar project ever attempted, and it's not about visiting. It's about living there. Artemis isn't just one rocket launch. It's an entire roadmap, a carefully planned sequence of missions designed to create a permanent human presence on the moon by the end of this decade. The idea is simple, but the goal is extraordinary. Build a sustainable outpost where astronauts can live, conduct research, and prepare for the next great leap, Mars. The plan starts with Artemis I, which has already proven that NASA's Space Launch System, the most powerful rocket ever built, can reach lunar orbit safely. Next comes Artemis II, scheduled to carry humans around the moon for the first time in more than half a century. But the real game-changer is Artemis III, the mission that will finally land astronauts, including the first woman and the first person of color, back on the lunar surface. This time, they're not landing anywhere near the old Apollo sites. They're heading to the lunar South Pole, one of the most mysterious and dangerous regions on the moon. Why there? Because it's believed to contain vast reserves of frozen water buried in shadowed craters, the single most valuable resource for survival. Water isn't just for drinking. It can be split into hydrogen and oxygen, creating rocket fuel and breathable air. In other words, water is the key to unlocking everything, from long-term habitation to interplanetary travel. Let's start with the most obvious problem. There's no air. The moon's atmosphere is so thin that it can't protect you from radiation, solar flares, or even micrometeorites, tiny rocks that can travel faster than bullets. A single puncture in a habitat or suit could be catastrophic. Then there's the temperature. During the lunar day, the surface can heat up to 250 degrees Fahrenheit, 120 degrees Celsius, hot enough to boil water in seconds. But when night falls, which lasts 2 full Earth weeks, the temperature can plummet to minus 280 degrees Fahrenheit, minus 173 degrees Celsius. That's colder than anywhere on Earth, even Antarctica. Now imagine your home, your power systems, your water supply, surviving through that extreme cycle over and over again. And then comes the lunar dust. It sounds harmless, just dust, right? But this dust is nothing like what we have on Earth. Lunar regolith is razor-sharp, electrostatically charged, and clings to everything. It can cut through fabric, damage machinery, and even clog air filters. A lesson NASA learned the hard way during the Apollo missions, when astronauts returned to their landers with dust coating their suits and lungs. To survive here, engineers need to reinvent nearly everything. Suits, habitats, energy systems, even tools, and they're already doing it. NASA and private partners are developing lunar habitats built from materials that can withstand radiation and extreme temperature swings. Some are testing 3D printed structures made from lunar soil, heated and fused into bricks using sunlight. Others are experimenting with inflatable habitats, lightweight structures that can be expanded once landed on the surface. Power is another massive challenge. Solar panels work well during the lunar day, but what happens when the sun disappears for 14 Earth days straight? That's where nuclear microreactors come in. NASA's Fission Surface Power Project is already developing small nuclear systems that can run continuously for years, reliable enough to power entire lunar bases. Even communication is a problem. The moon has no internet, no satellites orbiting close enough for constant coverage. At least not yet. That's why NASA is launching LunaNet, a space-based internet for the moon, allowing rovers, bases, and astronauts to stay connected in real time. But the biggest challenge isn't the dust, or the cold, or even radiation. It's distance. The moon is about 240,000 miles away, far too distant for instant help. Every tool, every spare part, every drop of fuel has to be sent from Earth at a cost of tens of thousands of dollars per kilogram. If something breaks down, astronauts can't just order a replacement. They'll have to make it themselves using whatever materials they have. And that's why NASA's engineers are focused on one mission-critical idea: self-sufficiency. The goal isn't just to survive on the moon. It's to thrive without constant help from Earth. But to do that, they'll need one thing above all: resources. And that's where the story takes a dramatic turn. Because the moon may not be as empty as we once thought. For decades, we thought the moon was just a lifeless desert, a cold, gray rock with nothing but dust and craters. But the more we've studied it, the more we've realized the moon is hiding treasures. It turns out, our nearest neighbor might be the key to the next great space economy. Let's start with the big one: water ice. For years, scientists suspected there might be frozen water in the moon's polar regions. But nobody could prove it until a few years ago. NASA's instruments confirmed what many had hoped. Massive deposits of ice are trapped inside permanently shadowed craters near the lunar South Pole, places where sunlight hasn't touched for billions of years. And this changes everything. Because water means life. It means air to breathe, water to drink, and, through electrolysis, rocket fuel to power journeys deeper into space. In fact, if we can extract and use that ice effectively, the moon could become a refueling station for the entire solar system. Instead of launching everything from Earth's gravity well, future spacecraft could stop at the moon, refill their tanks, and head to Mars or beyond at a fraction of the cost. But water isn't the only thing the moon is hiding. Its surface is rich in valuable minerals, elements that are becoming increasingly rare here on Earth. Lunar soil contains titanium, aluminum, and silicon, essential for building bases, solar panels, and spacecraft. But perhaps the most intriguing element of all is helium-3, a rare isotope that could one day power a new generation of clean nuclear fusion reactors. There's so much helium-3 trapped in the lunar regolith that, if we could mine it efficiently, it could supply the entire planet with energy for centuries, without the radioactive waste that comes from traditional nuclear fuel. That's why countries and corporations are suddenly so interested in the moon. It's no longer just about exploration, it's about ownership. The United States, China, India, and Russia are all planning missions to map and eventually extract lunar resources. Private companies are joining in too, racing to develop mining robots, processing stations, and transport systems that can operate in lunar gravity. And here's where things start to get controversial. Unlike Earth, there are no clear laws governing who owns what on the moon. The 1967 Outer Space Treaty says no nation can claim the moon for itself, but it doesn't clearly say anything about corporations or individuals. That means we're heading towards something humanity's never faced before: a cosmic gold rush. Whoever builds the first infrastructure, mines the first ice, or extracts the first helium-3 could become one of the most powerful forces in space history. And for NASA, Artemis isn't just about exploration anymore, it's about establishing presence before others do. But resources alone aren't enough. Even if we find water, mine minerals, and build bases, none of it matters unless humans can actually live there long-term. So how do you build a society on a world with no air, no plants, and no natural protection? That's the next chapter in this lunar story. Imagine waking up on the moon. You look out the window, and instead of blue skies, you see endless gray dust, stars that never twinkle, and Earth, hanging in the distance like a glowing marble. That's the world future astronauts and maybe settlers could soon call home. NASA's vision isn't just a base for science. It's the blueprint for a self-sustaining lunar community. Habitats will likely be buried beneath the surface or covered with lunar soil to block radiation. Greenhouses using recycled water and hydroponic systems could grow food. Oxygen could be extracted from lunar rock, and solar farms would provide clean power. And with the Lunar Gateway orbiting above, constant supply missions won't be needed. The moon could become humanity's first off-world hub, a place where science, exploration, and industry coexist. It's not just survival anymore. It's the start of something bigger, a new chapter in human civilization, written beyond the Earth itself. But before that dream becomes reality, there's one question left, the one that could decide the future of space exploration entirely. For thousands of years, humanity has looked up at the moon and wondered what it would be like to stand there. Now, for the first time, we're not just standing on it, we're planning to stay. The Artemis missions aren't just about exploration. They're about evolution. They mark the moment when humanity stops being a one-planet species and begins building a future among the stars. The moon is our testing ground, a place where we'll learn how to live in harsh environments, grow food without sunlight, and build homes out of alien soil. Every experiment, every step, every risk will teach us how to survive beyond Earth. Knowledge that will one day take us all the way to Mars and beyond. But maybe the most